Welcome to the introduction to virtualization. My name is Philipp Brune from Neu-Ulm University of Applied Sciences. Virtualization is a very important concept in modern data center operation, as well as on the desktop at home. The concept of virtualization basically refers to the provisioning of any kind of virtual, which means not physically existing, not physically present environment. And an environment could denote either hardware or an operating system or an application server or something. So any kind of runtime environment that allows to execute specific applications or specific software. This could be applications, it could be operating systems, depending on the kind of virtual environment. And the idea is that we have a dedicated hardware or hardware-software solution to allow for, or only software solution to allow for creating such kind of virtual environments. The basic concept is always to split up a physically existent computer resources, which means that there are physical existing CPU, RAM, I/O devices to create multiple virtual runtime environments. And this concept is nowadays very popular. It is used frequently also on the desktop. We have desktop virtualization techniques like VirtualBox or VMware, for example, that allow to use virtualization on a laptop, on a PC. But on the other hand, it's very important in the data center. Why? Because it allows to improve the usage of the existing hardware in a way that you get more out of the existing hardware, because you can consolidate multiple servers into virtual servers on one physical server, which allows to have a higher average resource use and to have the possibility to improve availability by a more easy switching from one hardware to another in case there's a hardware failure, and also to run, for example, different operating systems on the same physical machine, different versions or different kinds of operating systems, and therefore sort of consolidating servers, simplifying administration, and bringing more things into a software-defined environment, which allows to more easily configure and change it. This is all well known today. We all use that in the data center on any kind of platform. But it is important to know that this concept of virtualization originated from the mainframe. And that was present already in the 70s. So it has a long history of until it sort of moved down to our ordinary laptops, PCs, and every device that we know. So virtualization is not limited to mainframe, but it's very important on the mainframe. And in the context of mainframe and enterprise computing, of course, it's necessary to understand what kind of virtualization techniques exist and how they are sort of used and implemented, for example, on the mainframe platform. When we classify the different types of emulation or different types of virtualization techniques, then we get a sort of hierarchy of 5 major categories or types of virtualization that we might use on a computer. The most radical and the most resource-consuming one is full emulation, or we call it also full virtualization. This means that the full hardware of a machine is emulated on another machine. So it's kind of a simulation of another machine in software. This is not usually used in production use because, of course, it requires a lot of resources, but it's mostly used for development, for testing. For example, when you develop mobile applications on a desktop computer to simulate mobile or embedded devices, when you develop embedded software and things like that. There are also open source emulators that allow to execute software written for another platform on the PC. For example, there's Box, QEMU, or Hercules. Hercules is interesting because it's a open source emulator that emulates actually the mainframe. So it's a software full emulation of the mainframe. In theory, it allows to run mainframe operating systems on a PC, depending on licensing issues. But for example, using Linux as an open source system, you can do that. The next and most common way of virtualization, which is less resource intense, is hardware virtualization. Hardware virtualization is actually what most kind of virtualization environments do actually. It means that a virtualization software called also a hypervisor, it provides guest operating systems with parts of the physical real machine and divides it into virtual environments. So basically, it needs to virtualize the I/O and the RAM, but not the CPU. And this makes it more usable in practice, or it's dominating technology for virtualization in the data center today for some years now. It means that you could run every operating system that would run on the real physical hardware in a virtual guest as well, without modifying the operating system. Because it basically runs on the real CPU that is divided into or split it up into parts for the different servers and virtualizes the environment. The next step, or the next less resource intense type of virtualization, is para-virtualization. Para-virtualization is also common in the data center today, and it's even common on the mainframe because there is something called the kernel virtual machine in Linux, and this is also working on Linux on-set systems. Para-virtualization means that the system does not emulate the full hardware or the I/O part or the environment part of the hardware, but that the software provides the guest systems a software API that the guest systems could call that behaves more or less like a real computer or real hardware. This of course requires that the guest operating system needs to be adjusted, adapted to that API, so it needs to be changed, and this of course is only possible with guest systems that can be changed, that are open source for example, or that the vendor is adjusting to that. The most common para-virtualization techniques is Linux kernel virtual machine, which is also, as I said, running on Linux on set, and Xen, which is also used in the Linux environment. Hardware virtualization products that are relevant are in the desktop and PC environment, for example, it's VMware or VirtualBox. But on the mainframe, it's of course the classical ZVM, that is the typical hardware virtualization hypervisor. So hardware virtualization is available on the mainframe for all operating systems. Para-virtualization is only available for Linux. The next less intense level, so it's with every level the resource consumption is reduced, but also the isolation between the virtual guests is reduced. So there are more. It's more likely that, for example, there is a breakout of the guest to the host or to another guest if there's a bug in the system. So the next step would be operating system virtualization, which has not such a big use in practice, but still it is used partially. For example, in this case, the guest applications are provided an isolated environment, which is more or less like a separate operating system, which is called a virtual machine, on one host system. This means that this works only with the same host system, so all guests need to have the same operating system as the host. So you can have Linux guests on Linux host, for example. Similar concepts have been implemented for Solaris, where this was called zones. And there's the OpenVZ project, which is implementing such kind of thing for open source for Linux operating system. And today, of course, the most hot topic probably is application virtualization, sometimes also called or referred to as containerization, which means that we do not have really a virtual operating system or guest operating system, but we only provide inside one running host system the guests' virtual environments, providing them with their own file system and own network stack and so on. So they see a virtual system, but actually they run on the kernel of the host system. So in this case, you can have only one operating system, namely the host system for all containers, but the containers have their own file structure, so they can have their own configuration files and their own users and their own network addresses and so on, and see sort of a separate system. This is a technology that is used in cloud applications very frequently, and the most prominent example is Docker. There are other kind of container solutions, Linux containers, for example, but Docker is the most important and commercially used one. So these are the 5 layers or levels of virtualization. In the mainframe world, we have on ZOS, we have ZVM, we have hardware virtualization, we have logical partitions, which are, we will see that soon, are also hardware virtualization. We have para-virtualization in the Linux domain with KVM, and we have containerization application virtualization with Docker, also on Linux. So finally, let's have a look on a very special kind of virtualization. It's also a type of hardware virtualization that is specific and very, very unique to the mainframe environment, and that is called logical partitioning. The mainframe platform provides the possibility to create virtual machines on the hardware, on the bare hardware, without installing an operating system, without installing ZVM. You can just by the hardware management environment, hardware management console, you can configure, divide and split up the real mainframe hardware into logical partitions. This is what is usually done with the mainframe. Logical partitioning means that splitting the physical hardware into multiple virtual machines, which are then called LPARs, logical partitions. And every LPAR is sort of a subset of the physical hardware. Regarding, it has some CPUs associated, some part of the RAM, I/O devices, etc. And it's running its own, or it hosts its own separate operating system. So in one LPAR you could have Linux, in the other one you could have ZOS, and so on. This is basically a hardware virtualization that is built in the system, so it's implemented in firmware, in microcode in the system. It's part of the physical box, and so every mainframe offers that. But it's still, technically, it's a kind of a hardware virtualization technique. And there's a software component called the Processor Resource System Manager, PRSRM, which is part of the system, which is basically responsible for resource allocation between the logical partitions. And it allows, for example, to configure which CPs or which PUs are working for which LPAR. And it allows also to define rules that at runtime, resources are moved between the LPARs, and not only by the administrator, but even automatically, depending on, for example, changes in the load in the different logical partitions. This all can be configured using the hardware management console, which is a central administration console of a mainframe system. Technically, it's a laptop with a special software on it that is used for configuring the system. It is shipped as part of the mainframe system. And inside the actual mainframe box, there's the so-called support element, which is also redundant. So there are 2 of them. The support element is again a PC or laptop device that is running a special software. And so it's possible to configure it centrally from the management console or even inside the box. But still, it's a separate software that is part of the full environment of the mainframe. So this is the basic idea of logical partitioning, and this is very powerful because it allows, for example, to move resources when the load increases in a certain partition from one to another, depending on certain boundary conditions and rules, in a dynamic and automatic way. Thank you very much.